Welcome to the Bytecode, where we look at smart contracts with the people who wrote them. I'm Rosh Shafu, and today's episode is very, very special because it's the first in real life episode. I have Konrad here. Konrad, thanks for taking the time.
Hi. Yeah, thank you for inviting me on.
Yeah, of course. He's gonna walk us through the module kit by Rhinestone. So, Konrad, briefly introduce yourself, introduce Rhinestone, and then walk us through the code.
Yeah, sounds good. So hi, I'm Conrad. I'm one of the co-founders of Rhinestone. We're building infrastructure in account abstraction, like specifically in modular account abstraction. So the idea there is kind of instead of building a monolithic smart contract account, you modularize it and you have kind of a pretty minimal kernel that kind of has routing logic and kind of like the basic logic you need in an account. And then all the important features are in kind of self-contained smart contracts, which we call modules. So yeah, and kind of at Rhinestone, we're building infrastructure to enable this in a secure and in an interoperable way. And one of those tools is the module kit, which we'll walk through today.
Awesome. Let's do it.
Cool. Okay. Yeah. So this is the reverse scrolling. Okay. Nice. So yeah, the module kit is a Solidity like development kit built on top of Foundry that has a lot of useful abstractions and kind of helper libraries that make it like super easy and seamless to build these modules. And kind of like the ideal end state that we want to get to with the module kit is that you don't actually need to understand how kind of smart accounts work, especially kind of how different implementations of smart accounts like the safe or the economy account or the zero-depth kernel, how they work. But you can actually just build one module once and then kind of like deploy to all of them. So yeah, as you can see here, there's so there's kind of a bunch of features. So the most important of these is kind of integration tests for ERC-437. That's like a pretty big barrier to like a lot of developers. It's like you actually need to understand ERC-437 quite in depth to understand kind of all the very niche like rules and kind of like restrictions. I'll get into those like later. But yeah, this kind of abstracts everything away. And then there's also kind of like different module types. So actually maybe I should explain that quickly in a second. And then also kind of like I said, there's different accounts that are supported. There's like a deployment helper, gas calculation helpers that kind of make it super easy to build these modules. But yeah, just quickly kind of to set up here. There's, like I said, kind of these modules are self-contained like feature contracts. And there's different types. So one of them is called validators. And basically kind of the role of those is they validate a user operation, so 437 like transaction, and then determine whether it should be executed on the account or not. So there you can implement different signature logics, you can implement passkeys, multi-sig, kind of anything you want really. And then we have executors, which actually call into the account. So if you're familiar with like safe modules, it's kind of inspired by safe modules that call into the account and can trigger executions. And that's especially useful for like automations and especially for transactions where you want to execute something and then get a return value and based on this return value execute something else. And then the third type here, there's actually a fourth type as well, which I'll get into in a second, is called hooks. So once again on the safe has something similar called guards. Or these days, I think they also refer to them as hooks. And basically, they get called before and after every execution.
Okay.
So you can basically enforce certain invariants or like security policies. You can do spending limits, that kind of stuff. And then the last type is just fallback handlers. So those are called if the fallback function on the smart account is called, and you can kind of add behavior. Like for example, if the account doesn't support on ERC20 receive or something like that, you can add a fallback handler that then makes it support it. So it's mostly future proofing, but there's some cool stuff you can build there as well.
Nice.
Cool. So should I get started?
Yeah, let's look at the implementation. Let's switch to
yes. Okay. In terms,
I've seen a lot of people switching to that recently.
Yeah, I think it's like the main thing that's still really annoying, and we're trying to come up with like workarounds there. Is like if you npm like install something like the module kit, you still need to kind of like create all the remappings, and you also need to install all the subdependencies.
Oh, okay.
So that still sucks.
Yeah.
But it is a lot better already. I think.
Is there someone working on native a native package? Isn't there someone working on native package?
Yeah, I think so.
Okay.
I think there's like a Rust package manager someone was working on. I forgot the name, but
Okay.
yeah, I haven't tried it yet. But yeah, for now, PNPM, I think is just a lot cleaner.
Yeah.
And then we have so we have accounts. Right now we have a safe module in here. Then we have some examples, which is like as you can see, is another Foundry kind of like, it's not a repo, but like a Foundry project, I guess, with like loads of module examples. And then we have different packages. And the main one here is the actual module kit.
Okay.
So actually, what I think could make sense to get started is looking at an example,
Yeah.
because that's actually how devs will use the module kit.
Yeah. Dollar cost average.
Dollar cost average.
Yeah.
Okay, let's go. Should we close the sidebar? Or I think it's
Yeah, it's all right.
So this is basically a module, and as you can tell here, there's kind of like a base for different module types that you can inherit, and also for session keys.
Okay.
And then we kind of like formatted it in like kind of like different, you have like the actual module logic, and like metadata. So yeah, in this example, kind of the main important function, I guess, here is like the DCA function.
Yeah.
So this can be called by an account. So you kind of have an account here that calls it. And then first of all, it'll create an approve and swap, kind of like approve and swap executions. So this is another library that's part of the module kit, which actually makes it quite nice to do like swaps on Uniswap. Just like import the library, approve and swap.
Nice. That's nice.
Done. And then, yeah, in this case, we just do like change like storage and then just execute it. And actually it becomes like really simple to just like do dollar cost averaging.
That's awesome. What's happening here?
Yeah.
Code simple batch and that stuff.
Yeah, so this is like more account, I guess, like specific.
Okay.
So we're working on an ERC called ERC 7579.
Okay.
And basically on that, there's a kind of a standardized way for executions and how they're formatted. So basically how it works is, I guess this is another repo, but it's basically you have an execution function, or there's two different ones. And then there's a bytes32 like parameter, which gives like the execution mode. And it basically allows you to like very granularly define what the mode is.
Okay.
If you want, I can quickly go to just show you here.
You guys did this implementation?
Yeah, so this is the reference implementation for the ERC.
Oh, I see.
So we're on the ERC, we're working with Biconomy, ZeroDev, OKEx, and some other contributors. But yeah, this is the reference implementation, and here we have the mode lib. So yeah, basically this is kind of, like I said, there's a bytes32 parameter. And then you kind of have 1 byte call type, 1 byte execution type. Then we have 4 bytes that are unused for future standardization. And then we have some extra bytes, like 4 bytes for a selector and 22 more bytes for mode payload. So basically here, in here, this is just abstracted away. We just say this is a batch execution. So then we can just pass in a batch, so an array of executions.
Okay.
Yeah, does that kind of make sense?
Yeah.
And then, yeah, so essentially what happens is here, this kind of execution is triggered on the message sender. So a smart account will basically, kind of the way we think about it is first during validation, it has the session key, which will be validated. And then during execution, the account will call the trigger, in this case, like the dollar cost averaging. Yeah. And then here in kind of like, in here, we basically create like a scoped access. So basically we create a scoped key that can be held, for example, by a relay or by a third party. And then we verify that kind of like this key is only used to swap from this token to this token and less than this amount.
Okay.
So kind of the idea with this module is the user can kind of like install it on their account. And then a third party, like a relay, can actually do, on a specific schedule, can do the dollar cost averaging.
Yeah, there was a uninstallation function too. What was that? There was like a for loop over all tokens or something.
Exactly. So here, this is also like not audited and also not super optimized. But yeah, so on install, this is called when the module is installed on the account. And yeah, in this case for this module, we just have an array of tokens and spent logs. which is just like spend in max amount. So we just set this.
Okay.
Yeah. Yeah, so that's an example of a module, and maybe I can give an example of a test.
Yeah, sure.
I think that's, let me see. This is a pretty complex one, actually. We're also playing around with the tree branching technique.
Yeah, shout out to Paul.
Exactly.
Yeah.
So that's super cool.
Yeah.
So yeah, maybe, yeah, I guess we can do, this one is quite complex, so maybe that'll be interesting, as you can see by the imports. So yeah, like I said, like in my opinion, like the biggest value add right now of the module kit is you have this like integration testing library. So we just like the contract is just called the Rhinestone module kit, and basically it allows you to create this instance for an account. So basically, what you can do is, in this case, it's actually quite extensive. But you can just call the function make account instance. And either you can just give it like a string name and it'll parse like default configs, or you can kind of like more granularly define like the initial modules that are active on the account. And then later on, what you can do is you can just call, let me see where this is. Maybe.
Oh, keyboard doesn't work.
Yeah. Forgot about that part. So yeah, let's see. Bit of an interesting setup. Maybe it'll be easier in like a smaller test.
Yeah.
So you have an instance here, and then what you can do exactly is you have kind of this abstraction library. So you can do instance.install module, for example, or instance.get execution ops, and then you can exec that basically. And basically, so I think this would be interesting to kind of chat about here. So in this case, there's this auto savings vault. So basically, kind of how it works. This is a separate module.
Yeah.
How it works is that the user can install it and then kind of create a configuration. And then every time they receive either a specific token or just any token, a fraction of that token goes into a vault.
Nice.
So it could be, for example, as a retirement savings.
Yeah, I love that.
And then here we set up the parameters, token in and the amount received. And then kind of this whole function basically, so here we pass in kind of like obviously the target value call data, and then it uses a session key as well. So we pass that in. And then what this actually does under the hood is it creates the fourth, it's like it will deploy the account if it's not set up. You can just call X like that, and it will actually like run the entire kind of integration test.
Okay.
So the user or like the developer, I guess, like doesn't need to actually like create an account. They don't need to know like does this use the safe? Does this use
That's
the
nice.
kernel?
That's nice.
Yeah. So that's an example of. I think this is like the biggest value add, I guess.
Okay. So you guys invested a lot in basically DevX.
Yeah.
Making it easy to create new modules.
Exactly.
Okay.
Yeah, exactly. Like that's the whole overarching kind of like purpose of the module kit. And if you want, I can dive into kind of like the code because this actually abstracts away quite a lot.
Yeah,
it's actually quite complex under the hood. Let's see. So let's go into the module kit. So we have another interesting thing about the module kit, which is I haven't really seen that much in Solidity libraries, is like if you're familiar with like TypeScript and stuff, like a lot of the time you'll have like a folder with like different files. Then you have like an index.ts file where you just export a lot of files. But no one, like you can't really do that in Solidity. So actually what we started doing, which is quite interesting, is just like we have kind of like top level files, which just like export different stuff. So instead of kind of like importing from like source/external/ blah blah blah, you just import from source/accounts, or for example source/modules has all the different kind of like module
Interesting.
headers. Yeah, it's like
nice refactor.
Exactly. Yeah. It's kind of like nice DevX, I think.
Yeah.
Because like a lot of these different paths is just like.
Oh sure. Yeah. I wasn't thinking about the developer.
Yeah. Exactly.
Of course. Yeah.
Because like
I was thinking about you guys.
Yeah.
It's not that big of a deal.
That's true.
But yeah, for the dev, yeah, you're right.
Exactly, yeah. Because the dev will install this as a dependency, right? So it'll be much easier. They don't need to actually understand the file structure.
Yeah.
So that's quite interesting. Actually, right now it breaks, or sometimes it breaks like Etherscan verification.
Okay.
Because actually, this is some like a really interesting. It is a bug like that we found out. Is basically like if you were to inherit from this file, just say you import only this scope from this file, and then you flatten it. In the flattened file, it will have all of these contracts and their dependency.
Yeah. Okay.
So yeah, that's an interesting bug. But
Yeah.
but yeah, I guess what should I dive into? As you can see, there's a lot of code actually in here. So this is kind of like the main file that you actually import from in the test.
Okay.
And it's kind of it has the function like make account instance. And then kind of it will use a lot of these other kind of like helpers or like 437 specific helpers to kind of like abstract that away. Let's see. This is another one of those. In here, actually, we import from dependencies and then we export them, which is also like you don't have to worry about like what are those dependencies. But yeah, I digress. So this is one of the main files. It's has the function exit 437, and basically this will abstract away kind of like the entire 437 flow. So like if you're not familiar, you basically have like this entry point contract, and then you have these entity called bundlers, and they will take a bunch of user operations, which are like 437 transactions, put them all into a single transaction, and then submit that to this entry point. And then the entry point will do the reverse. It will loop over all the transactions and send them to the account and so on. So yeah, this is kind of like abstracted away here. And also like another quirk about like 437 is like if one of the user ops reverts, it will actually not revert the transaction. It will just emit an event. So you can't do vm.expect_revert. Okay. We actually have to go through the logs, find the right
That's
log,
nasty.
and then determine kind of like whether that's right. So yeah, that's a pretty interesting one. And then we also have kind of like a calculate gas helper, which will break down your user operation into like different phases. Okay. And then it will kind of calculate the gas for the different phases. And another interesting thing is it will also calculate the gas that you'll spend on an L2. So basically on L2s, like you pay both for execution gas on the L2 and then for call data gas on the L1, or I guess blobs soon. So it'll actually kind of measure both of those and then give you kind of gas units so that you can calculate the dollar amount of that. Which is quite interesting. I'm not sure if we have an example in here. Yeah, so it'll look kind of like this. So you have, on one hand, you have kind of like, obviously you just have the total gas, you have phases. It's like creation of the account, how much is it, execution, validation.
Interesting, yeah. Okay, nice.
And then for call data. And this actually, it's not 100% accurate right now, but this also includes kind of the compression that the L2 uses. So yeah, it's aimed to... So basically, for the call data, we will kind of right now, like I said, it's not like the most accurate, but we will
try to actually doing the compression.
Yeah, we'll try to like get the compression, nice. Like simulate that.
What is this library?
This one.
Yeah, libzip.
It's just from Solidity.
Solidity. Okay.
Yeah. Nice. This is not 100% accurate because Arbitrum actually uses broadly compression. But like libzip is kind of close enough right now. Yeah. But yeah, and then kind of for OP stack, it's actually kind of different because there's a constant and a scalar. So we calculate it that way. Okay. Yeah, it's kind of like in the weeds. Yeah. And then also, obviously, kind of like writing to the JSON file. You need to do a bit of like parsing and stuff like that. And one interesting thing as well, which Foundry does, if you kind of run a snapshot and then rerun the snapshot, it will kind of like compare. It will compare the gas diff. So we do that as well, actually. I don't know. Yeah. So if you were to run this again, it would have in brackets. It would have change and then the gas diff. So we actually need to kind of parse this JSON, get the number amount from in here, and then like do the maths. Which is also
which is really nice in Solidity.
Yeah, exactly. but it's good for the developer because it's abstracted away for them.
Yeah.
Um, and then, another helper that I think would be quite interesting to go through. It's actually in a separate repo, so I can open it on GitHub. But another quirk about 437 is that there's basically very specific rules that need to be followed during the validation phase. And the reason for that is you have it's like DOS protection for the mempool. So 437 has an alt mempool with these like kind of pseudo like block builders called bundlers. But you can have, for example, you could spam the mempool with a lot of transactions that take a lot of compute to verify. And then you could kind of like submit one thing on chain that reverts all of those. So all of the bundlers will have spent all of the compute and won't get rewarded at all. So in 437, there's like different rules on like opcodes you can use, on like storage slots you can write to, and like calls you can do, for example, during the validation phase. And if you're a bundler, so if you're like this like off-chain entity, it's actually not that hard to simulate, especially in Geth, because you can just do like a trace call. But in Foundry, it's hard. So let me
Interesting.
open up.
Oh, you wanna go back to GitHub?
Yeah.
Okay.
So we have a separate repo for this because let's just go back to Rhinestone because it's useful for other people as well that don't use the module kit. Like some account builders are actually using it to test their accounts. But let me dive into the code here. That's why it's a separate repo. It was originally part of the module kit, and we just like moved it out.
Okay.
But yeah, it consists of. Do you think we should clone this, or it's fine?
That's fine.
So it consists of this like simulator file, which is kind of like the high level entry point, which is a library, and you basically just have a function simulate. You pass the user operation at the entry point, and then it will kind of like route. And another quirk, not quirk, but like 437 has a v0.6 and recently a v0.7, in which the interface actually has changed.
Okay.
So this this struct is actually changed now.
So it's still changing that frequently? I thought it was kind of okay.
Yeah, it was. So v0.6 was deployed a year ago, and then v0.7 was deployed like a week ago. So I guess it is like a change in a year. But there's been a lot of kind of like not backlash, just like people arguing like back and forth, like should the standard actually change that much? Because this like the v0.7 upgrade actually breaks all accounts, all bundlers, like everything that's deployed.
Oh wow!
Like you can upgrade, or like you can stay on v0.6 as well.
Yeah.
So it's not like.
But it's not backward compatible, I guess.
Yeah, exactly. But yeah, let me show you. So this is the main file in here, which I just call like the spec parser, and basically it has this like entry point parse validation, which will be given account accesses. So this is like from Foundry if you call vm.record access. And then also the details from the user operation, which let me just show. Where's the struct? I'm not sure, but it just has some details basically.
Yeah.
And then it breaks down the different kind of like components that need to be checked into separate functions. So for example, validate the ban. And like storage location, disallowed calls, disallowed Xcodes, and so on. And then this is actually still to do because this actually needs a new Foundry cheat code, because you can't kind of get the so in 437, like I said, there's like some storage locations that you can use. So this is this is the most complicated ones. Actually, let me dive to the other ones. So there's some restrictions on like calls and Xcodes kind of accesses. Where you can only kind of like call to addresses that have codes or like not call with value and stuff like that. So that's relatively straightforward. Say with like Xcode, and then create. There can only be one create, which has to create kind of the account. That's quite alright. But the main one is the storage accesses. So basically on 437, in the validation flow, you can access, like an account can access its own storage.
Mm.
and then other staked entities can also access their own storage.
Mm.
But then external contracts can only access specific slots. So one of those slots is the slot where the key is the account address.
Mm.
Another one is slots where the pre-image of the key includes the account access. So you can basically have mappings. But it has to be kind of like, if you have a nested mapping, it has to be the innermost mapping that includes or it has to be the innermost key that includes the account.
Yeah, I have a general question about the spec. So the spec seems really detailed. Is everyone really enforcing this?
Yeah, that's a good question. So right now, like most bundlers don't actually enforce
They
it.
don't.
They don't enforce it, yeah. There's also like, so 437 introduces like the alt mempool, but the mempool isn't live yet.
Oh.
So right now you just basically call an API to a specific bundler. But it'll be interesting in the future because the rules are actually to protect the bundlers. So the bundlers can enforce them if they don't want to be like DOS, or like if they don't want to have kind of like an attack vector on them, basically.
Okay.
But on the other hand, it also makes it like a lot more annoying for account builders or like module builders. So I think yes, it'll be very interesting to see. But the bundlers that actually use the mempool, they'll enforce the specs.
Okay.
Because otherwise, yeah, they can just do DOS. Yeah. And then yeah, I guess. So and that this function basically checks if its current storage slot on a specific account is associated storage. So associated is kind of what I was talking about earlier. Is kind of like either the slot is actually the account address, or it's like like a mapping where the final key is the account address. So yeah, this basically kind of like checks it. For example, you can get the mapping parent. Yeah. So that's kind of it on the specs parsing.
Okay, sure. Let's switch.
Yep. Yeah. So this is kind of integrated into here as well, as you can see. So if you want to run this, basically just like kind of the command, just like you put simulate equals true push test, and then it will run. Like it will also simulate the user ops.
Just out of interest, where's the env from?
That's a VM cheat code.
Ah, it's a cheat code?
Yeah.
Okay.
So and another thing in here is because this is not a test, like none of these kind of like files here are tests. We actually kind of remap the cheat codes. So we have like functions for these, and then we just call the functions on the VM address.
Okay.
Yeah, because otherwise it would have to be a test, and it would be kind of annoying.
I see.
So yeah, these are all kind of like the cheat codes that we're using.
Interesting. Another general question, Conrad, like I can like the opcode validation, right? Or the storage slot validation. Everyone needs to check that, right? Like everyone who builds accounts abstraction or 337 has to check those. Like, isn't someone building like a general library for this stuff?
Yeah, so the like that library is like our attempt at building that general.
Oh, that's
library.
your attempt. Okay.
Yeah.
Anyone use that? Okay,
Exactly.
Okay.
Yeah.
I see.
So as far as I know, it's the only library out there today. So far, what people have just done is used Hardhat. I know you're a big fan of Hardhat. But basically, in Hardhat, you can have like a get node running, and then actually simulate on that get node, and kind of like do the trace call that I was talking about earlier. So that's it's actually pretty hacky and like really annoying. For example, I know the Biconomy team, the only reason they were using Hardhat is for this.
For that feature.
So yeah, now yeah, with that Solidity library, like with the Foundry library, it'll be much nicer.
Yeah.
Like I said, it's almost done. We're just waiting for a cheat code.
Okay.
But yeah.
Nice. That's cool.
Yeah. I'm not sure if there's something else you want to see. Do you want me to go into anything else?
No, I think we're at 30 minutes. This was interesting, man. Yeah. I didn't expect that that there was so much going on behind the scenes, to be honest.
Yeah.
Yeah.
Yeah, it's interesting. Like we try to like abstract like as much away as we can.
Yeah.
But that actually means there's like under the hood, there's actually quite a lot of
The
complexity.
developer experience quite nice. Let us look one last time. Like, if I'm a dev,
Mhm.
how do I implement stuff?
Yeah. So I can. So
One last example.
one last example.
Yeah.
Yeah. So like obviously, if you're an actual dev, you would kind of like import this as a dependency. But we have some examples in here.
Yeah.
One last example. Let's see.
Let's use what's a dead man switch?
Dead man switch over here. Yeah. So like the idea of it is basically just like you have. If for some reason like you die or like kind of like you disappear or something, like after a certain period of time that you set, like someone else can kind of like transfer the assets out of your account.
Okay.
I think I can. That one's interesting, but maybe this one is more interesting.
Okay.
Cold storage. So kind of like the idea there is, you have an account, and basically you can add these modules into it so that you can define that certain assets can never leave that account. So it's kind of like if you had like a ledger, like an actual cold storage, and then just transferred it and then like locked it away. It's kind of like that, but for smart accounts, which is quite interesting. So it actually consists of different modules. So these two mainly. This is the most important one.
Yeah.
And then there's also two more, which actually allow you to flash loan out that asset. So say you have like an NFT, and you put it in cold storage, but then you actually want to claim some utility or claim an airdrop from it. You can flash loan it out, claim the airdrop, and then it's returned into the cold storage.
Nice.
So this is a hook. So like I said, like it runs kind of like before and after execution.
Yeah.
And we have a nice helper here as well that actually kind of instead of kind of you needing to parse kind of which function was called and so on, it actually gives you this interface where you have let's see where you have these functions that you override. So for example, on execute batch, on execute from executor, like uninstall module on uninstall module. So it's actually quite a nice developer experience because you don't have to kind of like parse the function signature, figure out like which function was actually called on the account that triggered this hook. But you can just kind of put it in here. And then in here we can verify that kind of an asset isn't like leaving the account if it's in cold storage.
Okay.
That's kind of the idea there.
Nice.
And we also have kind of like a time lock on it. So if you actually want to remove the asset from your cold storage because like you want it back, then you can create a time locked or like request a time lock. And when you install the module, you will let me just show you up here. You will set the wait period. So for example, like 7 days, and then kind of you can request that, and then after 7 days you can actually claim it. So verify that you actually waited for those 7 days.
Nice.
Yeah.
No, really cool stuff, Konrad. I think that's a great developer experience at the Oxford.
We had some pretty good feedback. One feedback was actually that it was too abstracted away.
Interesting.
But that was from someone that has spent like a lot of time building safe. And then kind of like we were a problem, right? Because on the one hand we want to abstract a lot away, but then on the other hand, if you really know what you're doing, like we also wanted to make it easy for you to customize how it works. So we're actually working on some stuff there that allows you to like customize it more easily.
That's awesome. Well, Konrad, thank you very much.
Thank you.
I'm gonna put the Rhinestone docs, Rhinestone GitHub, your Twitter, Rhinestone's Twitter, in the description down below. Anything else?
I think that's it.
Do you guys have a Discord or something?
No.
No, Discord.
No Discord.